These examples here for our note today have a mixture of types of factoring. So what I suggest you do is you have your summary of factoring out in front of you and walk your way through that decision table, that factoring tree, or whatever you want to call it, and see if you can figure out how to factor each of these examples. Now they do have some twists and turns and things in them, and I have kind of grouped some of them together just because they're similar to one another. But treat it like a little quiz. Quiz yourself here. See what you know. See what you need to spend some more time on. And then use the video to support your understanding. So I go through every example and explain it. You might want to fast forward through some examples if you know what you're doing. You might want to fast forward just to check, but if you're stuck, please, please, please listen to the explanation so that you can better understand where it is that you're going wrong. Okay, so put the video on pause, give these questions a try, and then check your work as you progress through them. Okay, this first example, I always want to look for a common factor first. If I look at this example, it does have 3 terms, but I know I can have some things in common here. If I look at 15, 12, and 9, 3 is part of our GCF. 3 is common. I have an x cubed, an x squared, and an x to the 1. The smallest power is x to the 1. And then I have an x to the 4, x cubed, x to the 5. The smallest power is x cubed. And then when I divide every term by the 3xy cubed, I'm going to get a 5x squared y for the first part, a minus 4. I need another factor of x to get x squared, and I already have my y cubed that I need for that term. And then we're going to have a plus 3. I have an x, and I only need one x, or x to the 1. I have a y cubed, but I need y to the 5, so I need 2 more factors of y there. So that is my factored form. If I look at what I have left in the bracket here, I do have 3 terms, but it doesn't follow that x squared x and no x's here. It follows that, except the y's don't follow in their reverse pattern that they sometimes can follow in. So I've got a y squared. This one doesn't have any y's, but this one does. So there's really no other type of factoring I can do with that particular example. All right, the next one is the one where we're working backwards to the expand and simplify 2 binomials. You'll notice the 4x minus 1 is common, so we could have a bracket with a 4x minus 1, and it is multiplying the 3x and the minus 7. Okay, or think of reversing that very first step of multiplying a binomial together. All right, next one. I have 36x squared minus 25. I'm looking, is there anything that's common to both of these terms? There isn't a number that can divide 36 and 25. The only one of them has an x squared. There's nothing common here. So now I look at the table and I see there's 2 terms, and it looks like it is a difference of a couple of perfect squares, which should be binomials that look the same except opposite signs. They're called conjugates of each other. So 36x squared, square root at that, we get 6x, that goes at the beginnings. We square root the 25, we get 5, that goes at the ends. You make 1 a plus, and you make 1 a minus. And there's nothing more we can do with that. All right, next one, I only have a 1 here, and this has a 9x squared. There's nothing common, first of all. Second of all, there are 2 terms here. I do have a perfect square because I can square root 1 and get 1, so that's going to go at the beginnings because I do have the difference of squares here. The square root of 9x squared would be a 3x, so that goes at the ends. And we make 1 a plus, and we make 1 a minus. So we've got 1 plus 3x and a 1 minus 3x there. All right, next one. I'm looking for anything common between all 3 terms here. Yeah, I got nothing. There's nothing common there. The number of terms, there are 3 terms. It does have that 1x squared plus bx plus c. We're going to look for 2 numbers that will add to the b, which is negative 7, and multiply to the c, which is 12. 1 times 12 multiplies to 12, 2 times 6 multiplies to 12, 3 times 4 multiplies to 12, and then I'm to 4 times 3, so I'd just be repeating myself. I'm multiplying to a positive, so they both have to have the same sign, but since I'm adding to a negative, they both have to be negative numbers. So then if I look at my combination, negative 3 and negative 4 will do that for me. And because it's a simple one, I know I have to have x's at the beginnings to get that x squared, and then I'm going to end up with a minus 3 and a minus 4. And that is as simple as I can go with that. All right, the next one, if I'm looking for a common factor, yeah, there's nothing common to all three of those. If I'm grouping, I'm really looking at 4 terms, which I forgot to put any grouping on this video. If I'm looking for my trinomial here, it is simple because I have a 1x squared. I'm looking for 2 numbers that will add to -3 and multiply to -18. I think -6 and +3 will do that. I'm just trying to tighten it up for time. You could go through all those factors if you wanted to figure this out. The factors of 18, that is. I'm going to have an x at the beginning of my bracket, and we're going to have a -6 with one of them, and then we have an x at the other bracket, and we're going to have a +3 with that. Now, the only thing with this one is we also have this y squared and this y. All that means is with the 6 and the 3, I'm going to add a y to it. I almost forgot to do that with the first one. So if we expand that, we get x times x is x squared. The x times the 3y is a +3xy. The -6 times the x is -6xy. So a -6xy plus 3xy would be the -3xy in the middle. And then -6y times +3y is the -18y squared here. All right, next one. If I look through this, I'm looking, is there anything common? Oh, ding, 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 ding. I've got a winner here. There is a common 3. So I'm going to, x is not common because the 24 doesn't have an x. So I'm going to factor everything or divide everything by a 3. I'm left with 3 multiplying an x squared minus a 6x and a +8. Now, key with this, I'm not done. Because once I common factor, I'm going to look at what I have inside here. I have a trinomial. I can find 2 numbers, I hope, that will add to -6 and multiply to +8. So if you think about that, I think 2 and 4 will do that, except they both have to be negatives so that they add to -6 but will multiply to a +8. So what that means in terms of my factored form, the 3 just goes along for the ride, and I know the x squared minus 6x plus 8 will factor to be an x minus 2 multiplied by an x minus 4. And there we are. All right, try the next one. Do we have something in common? Why, yes, we do. We have a 2 in common. Everything here can be divided by 2. I have so much fun making these videos. All right, and now I have a trinomial left inside as my quotient. I'm going to look for 2 numbers that add to -2 and multiply to -24. I believe 6, a -6, and a +4 will help us out with that. And that means my factors then will be an x minus 6 and an x plus 4. All right. Next, common. Oh yeah, 4 can divide all of those, and not just 4, an x can go with that too. So I'm going to divide everything by 4x. That's going to leave me with an x squared in here. 12 divided by 4 is a +3x. 40 divided by 4 is a minus. We're going to have a -10 and no x's. All right, that is a nice little trinomial in there. Let's see if we can find 2 numbers that will add to 3 and multiply to -10. Ooh, let's see, 1 and 10, nope. 2 and 5, ooh, I could potentially get a 3 out of that. My signs have to be opposites. I'm going to make the 5 the positive one so that I would add to a positive. Yep, there it is. 4x comes along for the ride, and these the trinomial breaks down into an x minus 2 times an x plus 5. All right, next, common, common, common. Is there anything common here? Yep, there is. An x is common for sure, but actually this one's tricky. Kids often miss this because 36 is a perfect square and 100 is a perfect square. But 4 divides both of those numbers. So 4x is my common factor again. 4 goes into 36 9 times, so I'll have a 9x squared. And a minus, 100 divided by 4 is 25, and I have no x there anymore. I don't have a trinomial inside that bracket, but I do have 2 terms, and if I follow my tree, my decision-making tree, that does look like a difference of squares there. So now the 4x goes along for a ride, and we're going to change that into the binomial conjugates of 3x minus 5 multiplying a 3x plus 5. All right, The next one here, ooh, I think we did this kind of an example in part B. I see that this bracket and this bracket are the same. So if I think about working that backwards, I'm going to have x plus 2, that's a common, and when I divide the first thing by x plus 2, I get an x squared. If I divide the second thing by x plus 2, I get a minus 9, but we are not done, because if I look at this bracket here, I see that I have a subtraction of two perfect squares. So this gets to be factored again. So the x plus 2 just goes along for the ride. I can't do anything more with that, but the x squared minus 9 becomes x minus 3 and an x plus 3. I'm square rooting the first, square rooting the last, make one a plus, make one a minus, so the middles will cancel out. All right, this last one. Anything common? Nada. However, it has two terms, it has a difference in between, and they're both perfect squares. Square root of x to the 4, I get x squared. Square root of 16, I get 4. I'm going to have two brackets that have an x squared and a 4, but one's got to be a plus, one's got to be a minus. I'm not done. I'm not done because this x squared minus 4 is another difference of squares. When you have a plus, there's nothing you can do with it. It is factored as far as it will go when you have those two terms and a plus in between. It will not factor. Trust me, it won't. You can try different combinations, but you will see that no matter how you break that up, it's not going to work. It's not going to expand to give you back the x squared plus 4. All right, the x squared minus 4, though, becomes an x minus 2 times an x plus 2. The binomial conjugates, difference of squares. I hope you had fun listening to that. I hope you understand better. That factoring is not just a one-time deal. Sometimes you have to go the extra mile and do another type of factoring within your question. But you always, always, always want to look for that common factor first.